So I've taken a look at subject of formula. In this video, we're going to take a look at equations, an introduction to equations, of course. Then we'll move on to linear equations. So we're going to start with an introduction to equations. So what is an equation? An equation is a mathematical expression with an equal sign. The equal sign shows that the value on the left side is the same as on the right side. For example, 2 plus 3. This is the simplest example of an equation. 2 plus 3 equals 5. We all know that. So what this means is 2 plus 3, when you add it in your head, what you're going to get should be the same as what is on the right hand side. Equal to means what is on the left should be the same as what's on the right. So 2 plus 3 is the same as 5. So we first started learning about equation when we were in grade 6, when we were doing that mathematics we used to call Yama box. So equation could be structured like this: 2 plus box is equal to 8. So your job was to guess what is in the box, and of course it's 6. So 2 plus 6 is equal to 8. But now the box has been replaced with x. 2 plus x is equal to 8. And instead of guessing, we are trying to discourage witchcraft. So what we do is you follow laid down procedures on how to get x. So we're going to start with a linear equation. In our syllabus, we're going to take a look at two types of equation: a linear equation and a quadratic equation. So a linear equation in one variable is an equation with the highest power of x being 1. So something like this is a linear equation. So long as your x has no power, or it has an invisible power of 1, then it's a linear equation. Of course, what I mean is this x has an invisible power of 1, but we don't show it. So any equation where the x has no any powers like 2, 3, 4, it's a linear equation. And to solve linear equation, we use what we are from learning on subject of the formula. We make the unknown or variable subject. So if we want to solve this equation, the variable x, there is usually one letter or one variable in the equation. So we make it the subject. Once you make it the subject, it means you have solved. So let's take a look at examples. So these are examples. So start with A. So x plus 1 is equal to 8. So how do we solve this? We take plus 1 this side, it becomes minus, so it becomes like this, and we have this. Question B, minus 3x minus 5 is equal to negative 8. How do we solve this? We chase this. If you remember, negative 3x is considered to be more close to x than negative 5. So we chase it this side, it becomes positive, and we're going to have this. Then after that, we divide both sides by negative 3, and we have 1. Then example C, how do we deal with this? So our wanted, or the term that we want, or the variable that we want, is down here. So to solve this, again, whenever you've got fractions, you do cross multiply. So when cross multiply, you're going to have 2x times 8 is going to be 16x, and negative 3. Remember, there is 1 here. You have to learn, you have to learn, not learn, you have to learn how to see that there is always an invisible 1. You don't have to show it always. So negative 3 times 1 is negative 3. Then from there, we'll divide both sides by 16 so that we remain with x. So when we divide, we have that as our answer. And finally, we have D. So this one looks complicated because of unknown here and unknown here. But the easiest way to do is you expand, then you collect like terms together. So we're going to expand it: 2x times 2 times x, 2x, 2 times negative 3, negative 6. And we're going to do the same here. So we're going to have this: 2 times x, 2x, 2 times negative 3, negative 6, negative 3 times negative x, 3x, negative 3 times negative 2, positive 6. Then from here, we combine like terms like this. Then when we add like terms, we're going to have 5x, and negative 6 plus 6 is going to be 0. And after this, we can divide both sides by 5, and we have this as our answer. So this is how to deal with linear equations in one variable. So the next part which we are going to take a look at is how to deal with simultaneous equations, which are also types of equations, but they involve two unknowns.